heard a lot of discussion about what blockchain can do in terms of, doing notarization, storing evidences. We already see courts ruled in legal cases using evidences saved on blockchain, which is very innovative for them. And also we know that blockchain is good at sorting out chaotic data and making chaotic data an ordered sequence of transactions. And also blockchain is providing a virtual trust party so that people can sign contracts with each other without a common intermediary like lawyer. And also, of course, blockchain has been widely used for payments and cryptocurrencies and so on and so forth. Everybody here has heard a lot about those things. And in terms of larger areas, people are talking a lot about blockchain and how blockchain would integrate with many other areas like AI, like big data, like finance, healthcare, etc., etc. The list can go on, and use your imagination to think about what other opportunities blockchain can bring to us. The promises are definitely exciting. Blockchain is fast, it's frictionless, it's transparent, it's secure, and decentralized, and so on and so forth. Very good promises. However, let's make the implicit explicit. In blockchain domain, this is almost open secret, right? We have a lot of aspirations. We want to build a whole new world based on blockchain infrastructure. However, when it comes to real implementation, comes to real technology, we see a big difference, a big distance between the two. So the aspirations is far from technology. That's unfortunate. And even more so, in the past 2 years, people have been talking about the alleged blockchain trilemma, which it essentially says that among the three properties, security, scalability, decentralization, a public blockchain can only hope to achieve at most 2 of them. Now the trilemma, first of all, is not a mathematically proved result, because if it is mathematically proved, then there's nothing we can do besides accepting the truth. However, the trilemma is used more like a way to emphasizing how difficult it is to achieve all three together. So the good news is that there is a large space for us to make progress in and to actually achieve all three together. And that is exactly what Algoland is aiming for. Okay, when we talk about Algoland, we typically say that we are an alternative blockchain. Why? Because we are not a fork of any existing project. We are not built based on any existing blockchain. And we built everything from scratch after observing the problems in existing domains, and we made many technical innovations which are developed from first principles, meaning that our technology is backed by solid mathematics and rigorous analysis about its guarantees, rather than based on heuristics. That's a big difference here. And also we design our chain to enable continuous evolution of the functionalities so that we can easily add new features in the future without interrupting the smoothness of the chain. Okay, in the next 40 or 50 minutes or so, let me give you first of all our team a brief introduction, and then I will focus on the core technology of Algoland. And then I'm going to talk about our roadmap, what we have done, and what we plan to do next. And there, I'm also going to share a lot of other things like incentives and auctions and smart contracts that I'm not going to cover in the core technology part. All right. In terms of the team, Sylvia is our founder. I'm also very proud he's my PhD advisor back at MIT. Silvio is a pioneer of cryptography. He and his co-workers laid down the foundation of modern cryptography back in the 1970s and 1980s. And then there are our Steve and Sean. Steve is a hardcore entrepreneur. We always joke that Algoland is the first company that Steve ever worked where he's not the founder. So he is very hardcore, and he has founded several successful projects already. And then this is our research and engineer Liz. Myself, we have many alumni from MIT and Harvard. Also many experienced leaders from industry like Microsoft, Mozilla, and other companies, very experienced. And also this is our advisor boards. I'm not going to go through everybody, but the people who are in the blockchain domain probably could recognize some of them. Also people from finance probably recognize, say, Andrew Law. He's a professor from MIT Business School. Ken is a former chief economist of IMF. And then we have our scientific advisors, faculty from MIT and Brown. And crypto advisors, where we have Ali. Ali is the founder of Zcash and also Naval, founder of Coinlist. So our advisor board has given us a tremendous amount of help and advices on our way, and given us many insights about how to build the next the roadmap for our grant. And this is a global investment group. I'm not going to go through all of them, but this is a very distributed. So like decentralization is at the core of our grant. So our investor group also from geographically from all over the world, profession-wise from all kinds of industries, background from different culture, different country. So we do have a very diverse investment group, which is something we are very proud of. Okay, so this is a very brief introduction about our team, who we are. And let me focus on the next part, focus on the core technology of Algoland, what we do, and why our technology is able to solve the alleged trilemma and be all three things: secure, scalable, and decentralized all at the same time. Okay, so whether we want the blockchain or not, a lot of people have an affirmative answer. It is a very good infrastructure. But the real question is, of course, how to implement such infrastructure, right? Building the chain is easy if you know how hash function works. You put the hash of the previous block in the content of the next block, then you change them up properly, and nobody is able to change the data in the previous blocks. But the real question is, of course, how to choose the next block. Who will choose it? How do people achieve consensus on that block? Those are the key questions a public blockchain protocol needs to answer. And in terms of existing approaches, we see a lot of approaches that have been here for a long time, such as proof of work, which is the foundation of Bitcoin and Ethereum and many other good projects. We also see other technology like proof of stake, especially delegated proof of stake and bounded proof of stake. In terms of proof of work, this is something that people have discussed a lot because Bitcoin has been there for like 10 years, right? It's really making a big difference in the world. Proof of work was not invented by Bitcoin. It was invented by cryptographers in the 1990s, and the original goal was to find scam emails, garbage emails. However, it's fair to say that Bitcoin has made proof of work to the next level and to the next scope. Nobody has ever thought about consensus can be achieved in this way, in this large scale. So it has inspired many of us to rethink distributed consensus. So Bitcoin as a first solution is really inspiring. However, we have also seen a lot of problems of proof of work, like consumption of electricity, like hardware cost, like concentration of power, because it's so expensive to mine Bitcoin. Right now, you can only join mining pools, and I think in the world there are about like 5 to 3 major mining pools will control about, say, 90% of the total mining power. So a lot of people have realized that such a system is not really a decentralized system anymore. There's a lot of concern there. In terms of delegated proof stake, the idea is to say that most users will delegate their right to the hand of a few pre-selected supernodes. And the supernodes will participate, and they have huge stake in the system, and they may be punished if they are caught wrongdoing in the system. In terms of having a few nodes, well, if you consider one node is monopoly, 2 nodes are duopoly, it's hard to think that 3 nodes or 5 nodes or 20 nodes are decentralized enough that the power is still in a few hands and they're in charge for a long time. So that also causes a lot of problem in the community. Now, in terms of bounded proof stake, the idea is the following, that each user has a balance in the system, and you decide how much balance you are willing to lock up without touching, say for 3 months or even longer time. And whatever you are able to lock up is your stake in the system to participate. And if you are caught wrongdoing, the system will punish you and take this money away from you. Now, if we think about, this is a system that would make small users hard to do it, because for small users, like it's similar to like having a bank account and you put part of your money in a CD account where you lock it up for 1 year or 2 years, and that money you cannot spend. I don't know about the people here, but in the US, it's very hard for a typical person on the street to have a CD account, to put money aside without touching. A lot of people have very little saving, and they need to use their balance regularly, day by day. So this system actually disallows small users from participating in the system. And it is the big users who have a lot of stake who are able to lock up a large amount. Therefore, they would have unproportional power in the system eventually. So unfortunately, this is really not really small user friendly or not really fair to small users. Now, what does Algoland do? Algorithms are based on proof of stake, and it is what we call a pure form of proof stake. This is what we do. We do not punish users. We understand that even an honest user sometimes make mistake, and this is unintentional. We use mathematics to show that even bad behavior is not able to do any damage in the system. Therefore, a malicious user will not be able to cause the system trouble, and therefore there is no need to punish them. And because they cannot do any damage anyway, their motivation about wrongdoing is also not big. Another point is that we do not ask users to lock up your balance. Your money is always at your fingertips. You can spend anytime you want, any amount you want. It is your true balance that counts as your voting power in the system. So this allows small users to easily participate. You don't have You spend the money, that's okay. You don't spend the money, you can vote in the system. The assumption we need is that most of the money in the system is in honest hands. This is similar to what Bitcoin assumes, that the majority of computation power is in honest hands. Otherwise, Bitcoin will suffer from, say, 51% attack. So this is the honest assumption in our system. In other words, if we look at the tokens rather than users, a user's voting power is strictly proportional to his balance. In other words, we do not discriminate tokens. Each token has exactly the same power in the system. It doesn't matter whether this token is owned by small user or by big user. So the tokens are really distributed and are treated equally. Okay, now after giving you some high-level ideas about our proof-of-stake technology, let me say something about how Algoland generates the blocks. And the way I describe it as the blocks can be generated effortlessly and one by one via balloting agreements. What are those? What do those keywords mean? So pictorially, the blockchain will just go like this. It is a chain. It does not have mining. It just go one block after another without interruption, very fast. So it's really like a chain, and the computation is really as light as a feather compared with mining, where a lot of work needs to be done. That is a picture of, say, Bitcoin's blockchain structure. We talk about the blockchain all the time, but really it is rarely a chain. It is really a tree, because there are many branches at the same height, and that's why people need to wait for a long time before your transaction can be finalized in the system. Well, in Algoland, it is really a chain. There is no branches. Therefore, what it means are two things. A, because there is no mining, there is no proof work, participation in the system is very easy. A user has a simple laptop and basic network access, will be able to run a node in the system. Second of all, because the chain is really a chain, there is no branches. It's really immediate final for any transaction on the blockchain. So we know that in Bitcoin, it is recommended that you wait for 6 blocks. And 10 minutes per block, you need to wait for an hour for the transaction to be sufficiently final in the system. But in Algoland, the finality is immediate. The moment the transaction appears on a blockchain, you are able to rely on it. And it will not disappear. So that's about finality. Okay. Now those properties are achieved by our balloting agreement. I believe a lot of people have been talking about balloting agreement for blockchain a lot. Let me give you a very high-level explanation about what balloting agreement does. This is probably the most technical slide in this talk. It looks like this. So, a balloting agreement ensures 2 properties in the system. First property is called agreement. It means the following. The system has a bunch of users, right? Some users are good, some users are bad. I hope from the picture you can tell which one is good, which one is bad. And each user has his own view about the system. Say, I see a set of transactions, you see a set of transactions. They may not be exactly the same. So maybe I have a view about what the next block should be, and you have a different view about what the next block should be. And after they communicate, they are able to individually reach agreement on what the system status should be. So they will start from something different, and they will output something that is always the same. So that would be the content of the next block. Now, the Bernoulli agreement has a second property that people do not talk about it often. But this is an important property that allows efficiency in our system. That is consistency. Meaning what? Meaning the Bernoulli agreement does not waste the system's power and does not force people to agree on something else if they already started in agreement. So in some good situation, the system is in good shape and people always have consistent view about what the next block should be. Then they communicate barely and they end up saying, yeah, this indeed should be the next block. So this part is very efficient. And agreement and consistency are the two properties that the agreement allows the system to have. However, we cannot allow, no system can allow millions or billions of users to participate in a Bernoulli agreement because computation efficiency and because network efficiency. In Algoland, our novelty is that we have our own Bernoulli agreement and super efficient that we can achieve consensus at a planetary level and with very high computation speed. So block generation speed is within seconds. About security. So now that I said a little bit about efficiency. Now let's talk a little bit about security. Now when we designed our system, we had a very strong adversary model in mind. And let me look at what the adversary can do. We allow the adversary to immediately take down any user, whether it is by DDoS, or by stealing the secret keys, or by something else. And once corrupted, the adversary has perfect control of all the bad users, what message they send, when to send those messages, and even to whom to send those messages. And also the adversary can attack both the protocol level and the network level, meaning that he can double sign wrong messages. He can also cut wires, take down routers, take down internet service providers, and so on. So this is indeed a very powerful adversary. The only thing that we do not allow the adversary to do is that it cannot forge signatures. In other words, the adversary cannot break more than cryptography. Because more than cryptography is the foundation for almost all internet-based transactions. Without it, there is very little we can say about the security of the system. So the adversary, without a secret key, cannot forge signatures. That's all we require for him, and otherwise he can do everything wrong. And indeed, this is a very strong adversary model, and our system is designed to be secure against such an adversary. So that's about the adversary model, and about the security. And let me say, well, we will not dive into technical details today very much. So I will just say a little bit about how we achieve security against such an adversary. The first innovative technology we use is cryptographic self-selection. Here's the keyword itself. What does it mean? It is similar like each user is able to secretly select himself to participate in a Bernoulli agreement. And it's like he's running his own secret lottery, that if he wins the lottery, he's able to prove to others that he does win. But if he's not the winner, then he's not able to cheat and convince others he's the winner. I always like using lottery system as an analog for cryptography self-selection. Imagine a lottery system. In the real world, let's say we have 1 million users, and we want to select 1,000 winners. So what the lottery does is that it prints 1 million lottery tickets, and 1,000 of them are winning tickets. Then the system distributes those tickets to users, and each user opens up his own ticket. Now he's able to show others, look, I have a winning ticket, it's saved here. Or he cannot fake the tickets. Therefore, he cannot cheat and tell others he's winning. So this is a system. This is how the modern, physical lottery tickets system is run. But digitally, a very crucial property here is that in our system, the users do not need to communicate with anybody in order to generate these lottery tickets. And this is crucial because without extra communication, the adversary is not able to know who he should attack. So we said that the adversary is able to take down anybody. But to him, the 1,000 winners are distributed uniformly among the 1 million users. So the best he can do is to randomly attack a bunch of them. And that greatly diminishes his power of controlling the winning users. There is one hidden point that I didn't say, but if you think about it long enough, you will realize what is the potential danger. We say that this is a lottery system where a user is able to print his own lottery ticket. Now that is a danger. Because if I'm able to print my own lottery ticket, I would print 10,000 of them, and I will open them one by one until I see a winning ticket. So as a malicious user, if I'm able to run the lottery machine for myself, then I will make sure that all my bad guys will be selected. So that is something very dangerous. That is why in the modern physical lottery system, the lottery tickets are all centrally printed. But in our system, thanks to technologies devised from cryptography, we are able to allow a single user to generate one and only one lottery ticket. Which means that even if you are able to print your own ticket, you cannot print two. You print once, it's this lottery ticket, you print another time, it's the same ticket. So you really cannot cheat and make yourself a winner. And by the way, this is done via what we call unique signatures. Unique signature, by its name, is a special type of signature scheme where if you send a message, there is a deterministic signature generated. And that is also related to what we call VRF, verifiable random function. And if you have heard those terms in the blockchain domain, those are the gadgets invented by Civil in the 1990s. And it's amazing that after 20 years, we have been using it for some critical properties of blockchain. All right. So given cryptographic self-selection, the structure of the protocol is very simple. It's essentially two stages. First stage, say one random token is selected. I'm not talking about selecting users. I'm talking about selecting tokens. Because really, as I said, in our pure proof state, each token has the same decision power as every other token. So it's really, each token gets selected, and it's the owner of this token who will carry out the functionality and propose a block and send it to the whole network. Now, in the second stage, another group, maybe 1,000, maybe more, maybe less, say 1,000 tokens, again tokens, are randomly selected. and their owners will carry out the functionality of the Byzantine agreement and will sign their outputs individually so that every user in the system will be able to tell this block is finalized. So the structure is indeed very simple. What else I haven't covered yet? Well, in terms of security, we see that the adversary is able to attack both the protocol and network. The network attack is actually a very strong attack that very little blockchain can sustain. What do we mean by network attack? Well, typically we imagine the internet as a big connected component. Like people send out the transactions, and transactions got delivered in the network, and they eventually reach all the users. However, some very powerful and determined adversary can, say, cutwares, destroy the cable underneath Pacific, or take down routers, take down data centers. So somebody who is willing to burn a lot of money can separate, say, Europe, Asia, or America for maybe several hours, or into at least several hours or a few days. In that case, what looks like becomes this, that transactions in different regions will be delivered within the region and cannot cross the border unless the adversary is doing something in middle. But in this case, the network is partitioned, and facing a network partition, what can an adversary do is very dangerous for a blockchain. Because secretly, an adversary may be able to convince a subset of users that one block is finalized, and is able to convince another subset of users that a different block has been finalized. And he can release them at proper time, and they may contain conflicting transactions. Therefore, by partitioning the network, the adversary is able to say double spend, or generating conflicting blocks. Now, this is very dangerous to blockchain, because if a blockchain's finalizing time is, say, 1 minute or 1 hour, then by partitioning the network longer than that, the adversary is able to create branches or conflicting blocks. And thinking about what would happen in Bitcoin is also dangerous, because in this case, people would just mine separately without knowing each other. Then the blockchain will have 2 very long branches, and eventually, when the network is resolved, one of those branches have to disappear. So finality is completely destroyed, because no matter how long you wait, one of those branches is guaranteed to disappear eventually. Therefore, this is a very dangerous attack to a blockchain. It is expensive, for sure, but when a blockchain gets successful and the value gets high, we got to be prepared for this type of high-stake attacks as well. So that's why we budget for such an adversary by designing a new consensus protocol we call Algoland 2.0. We are pretty bad at making up names, so it's 2.0, and it has been implemented in the system. It will be what we use when we launch our mainnet. So in this new protocol, besides using the previous technologies, and besides being super fast, it is partition resilient, meaning that the adversary will never be able to create 2 conflicting blocks in the system, no matter how long he partitions the network. And of course, when the network is partitioned for a long time, it is possible that nobody is able to finalize any block. But at the moment the network partition is resolved, the system will automatically recover and then continue generating new blocks. So being resilient and being able to recover quite fast are the two strong guarantees of our protocol. Okay, I think I do not want to make this talk too technical because I want to keep enough time to talk about our roadmap and stuff that people are interested, have been asking a lot of questions about. So let's just quickly summarize what are Algorand's main technical advantages. First of all, computation here is almost trivial. We do not need people to solve difficult cryptographic puzzles. All a node needs to do is to calculate some hashes and sign some messages. And we do not discriminate nodes or tokens, so all tokens have the same decision power, and it's really a decentralized system. And we do not have soft forks, so there are no branches in the system, and transaction finality is immediate. In terms of efficiency, because the system has a very low computation and communication cost, it can easily scale to millions or even billions of users in the system. And also about security, we do take security very seriously, and as I told you about, our system is secure against a very bad adversary. Okay, so that is all I want to tell you today about our core technology. And now I think we have, I don't know how much time we have left, but let me take the remaining time to tell you briefly our roadmap and our other important gadgets in the system that we didn't cover before. First is about incentives. A lot of people ask about the incentive schemes, and incentive is indeed an important gadget in a blockchain ecosystem. And in Algorand, our incentives will be designed for several stages. In the first stage, we are going to reward all users. We are not going to distinguish whether you are a relay node or a participating node or just a small user who has some stake in the system. Because at the beginning, we believe what is the most important is to be part of the network. Therefore, as long as you have some stake, you are eligible to receive our network incentives. And this also diminishes the requirement for a user to say give your public key, give your secret key to a big entity and let them participate for you on a staking service. So in Algorand, because we reward all users, you do not need to use staking service. If you want, of course you could, but you are going to receive the same network incentive no matter what. So that we believe is an important step towards distributing growing the network. And gradually, in the future, we will iterate and add more incentive structure on top. And we will reward users for different user groups, like if you are a developer, if you are a relay node, if you are participating in the validating agreement, if you you contribute to the code quality, like we have bug bounty, etc. So we have both online incentives and offline incentives. And the main design starting point of our incentive scheme is to encourage small users to join the system without incurring large costs, and to help the network to become decentralized a long time. So this is about incentives. I believe a lot of people have asked this question, so let me clarify here about our schemes. Okay, another important gadget in the system is auctions. Algorand's auctions will be run by the Algoland Foundation, And Algoland Foundation will release specifics of our Argo token auctions very soon. Today I'm not going to talk about the specifics about this auction, but I'd like to share with you our design and the motives and design choices about these auctions. So why we choose auction is because we want the market to do price discovery rather than ourselves made up some numbers and say the token is worth XYZ dollars, and then it's a fixed price. Fixed price is not really fair and doesn't really reflect how the market thinks about the tokens. So we'd rather to have an auction and let the market determine the price. Another thing is that, yes, we are going to use the revenue generated from the auction to fund the Algoland Foundation. In terms of the style of the auction, is a Dutch auction. Some of you have heard about it, some of you are new to this concept. I'm not going to tell you the details about how Dutch auction is run. But Dutch auction is a very classic auction that has been there for many, many years. We are not reinventing the wheel. Rather, we decide to use something that has been tested by the market. For example, well, the name probably comes from the flower auction in Netherlands. That this is still very popular in Amsterdam, for example. Also, say the U.S. Treasury Department used Dutch auction to sell bonds. That is a small scale, very few participants, but generates a lot of revenue for the US government. And also, since 1981, I think Dutch auctions is also used for share repurchase of firms. And you can find examples online about the companies using this to do their repurchase. Now, why Dutch auction is very popular in economy and has been widely studied because it has several very good properties. First of all, as in any other auction, here is the buyers who decide the price, not the sellers. So we let the community decide how much you want to bid for in the auction. And the second is that Dutch auction is very fair. Meaning that all the winners of the auction will pay the same price. So it doesn't discriminate users. This is different from some other auction formats. Dutch auction is famous for being fair. Another good property of Dutch auction is that it respects people's budget. It will never ask a user to pay more than what you intended to pay. So a user may be to say that I'm willing to put $5,000 for this auction, and at the end, he will never be asked to pay more than that. And also, if a user decides I want to pay for an item no more than $5 per item, then at the end, he will never be asked to pay more than $5 per item. So Dutch auction is really safe for users to participate and will not surprise users with a high price. And what it is good for? Looking at the examples, and if you look into its mechanism, you realize that Dutch auction is designed to sell many identical items. Whether it's flowers, like a lot of flowers can be considered identical, whether it's shares or bonds, those are also considered identical items. So Dutch auction is good for selling identical items. And another good feature of Dutch auction is that it can be easily conducted online. That is important in this distributed world because you cannot hope to have 5,000 users all in the same room to run an auction. The US government is able to do that for maybe 10 participants of big banks. But in this decentralized world, we are facing thousands of small users from all over the world, and and we must run the auction online. The Dutch auction has this feature that you can come and go. You come and place your bid, then you disappear from the system. That's okay. Your bid will be documented and the system will eventually clear considering it. Rather than other auction formats such as English auctions, if you have heard about the name, that is an auction that would require user to repeatedly act in the system, which is not good for online auctions. Because if the auction lasts, say, for 3 hours, in Dutch auction, a user may only be coming online for a few seconds to place his own bid. But in an English auction, a user does need to stay all 3 hours and keep on acting and acting. So this is another good feature of Dutch auction. And also, Dutch auction has many formats, and we designed the auction to fit the blockchain domain. And for example, one feature is that all the bids will appear on our own blockchain so that everybody can check how many bids have been put and what they are and what is the outcome. So we guarantee transparency on our own blockchain. Now, in terms of auctions, I'm not going to say too technical about the details, but the Algoland Foundation will release more guidances very soon. So stay tuned for that. All right, about smart contracts. A lot of people have been asking about smart contracts, and Algoland does plan to support smart contracts on top of our platform. So our first go-to-market is a transaction platform, and we plan in the future to become an infrastructure where we allow developers to build their own project based on our blockchain. However, if we look at existing smart contract platform, we see that like Ethereum has been very successful and is really a pioneer in the smart contract domain, and there are many applications built on Ethereum. However, we also note that the efficiency of the system is largely affected by the amount of smart contract in the system. You need to wait for a long time for the contract to be verified. The gas cost is also pretty high, and more, every once in a while we see some attacks launched for smart contracts that would cause a lot of economic losses for the owners of the contracts, right? So those are because the smart contracts are not efficiently designed, are not securely designed. And in our system, our roadmap, our vision about smart contract is a multi-stage paradigm. So we will develop our smart contract infrastructure via several iterations. At the beginning, it will be some very simple logic, some simple template-based smart contract that would support very simple transactions like atomic swaps, for example. That is very important stuff, right? So we will choose these simple but important features in our first implementation of smart contract, and then we will gradually extend the logic set to make it support more and more features. And the design, the motivation of this choice is to ensure that whenever we add a logic feature, we make sure that it is secure, and we make sure that the developer tool is well tested and well designed, well deployed. So efficiency and security are the two motives for our paradigm of smart contracts. And indeed, I believe our smart contract platform will first give people simple and usable applications, and gradually will support more applications, and eventually we would have very powerful virtual machines at the end. Okay, about how to participate in the network. First thing first, I'd like to emphasize that Algoland is a permissionless blockchain that everybody is able to join, is able to be a node in the system. And the nodes will eventually become different functionalities. However, we give all these options to all the users. So if a user is small, he just wants to transact, he can rely on our mobile client. So you transact, you do not need to participate in the consensus protocol. If a user has a laptop, basic network, he can be a regular node who would participate in the consensus. If a user has a good internet resource, he can choose to be a relay node. And in the future versions, we will add more incentive mechanisms, as I said before, to encourage more diverse and active participation behavior in the system. So in any case, we give all the users all these options, and we let the users choose what the user want to do in the system. Okay, in terms of development, we consider ourselves internally at 3 stages. First is the proof of concept stage, our internal operating environment, and then the testnet, and then the mainnet. We are currently at stage 2, where we have our testnet running. It has been running for more than half a year now, and it has many partners and developers who are enthusiastic about being part of the network have been joining us. One thing I'd like to emphasize is the following, that for the past half a year, the network is application and approval based, so that it's mainly open to volunteers and partners. Since last week, April 16th, we made the testnet open to everybody. So right now the testnet does not have approval. Everybody can install a node and try out the testnet. And I also encourage everybody to give it a look and see how you may be part of the network. So that is something we are very excited about, and I hope to see many people here to be on the network. And in terms of how do you participate, this is a very important resource, our developer community, developer.algoland.org. And if you go there, you will see instructions about how to set up a node, and you will also see many other things, like we provide all kinds of developer tools, APIs, so that the user can use to build your own projects. And in terms of developers' language, we are continuing developing tools. And we believe it is good to be diverse, and we want to allow developers to build using your favorite language. So right now, we provide Go SDK, Java SDK, and JavaScript SDK. And in the future, we plan to develop more support for other languages. So this is a developer-centric platform, and we want to make it flexible for everybody to build your own projects. Now, this is something you typically do not see if this is an academic talk, because, well, in terms of proof of concept, nobody cares about code quality or documentation, but in terms of industry-level product, we do take code quality very seriously. So we have partners doing code review for us, and we have thorough tests, and we have well-prepared documents. We are proud to provide, to say that we take code quality seriously, and I hope that will make it easier for developers to join the community and take a look at what we have right now. And also we have, as I said, Algoland eventually will become a platform where a lot of people is able to build on top. Right now we have our partners building their own use cases on top. We haven't announced the details yet. So at a high level, there are all kinds of things like e-wallets, assets, online games, and so on. In the future, we would have other use cases on top as well. And of course, this is an open platform, it's permissionless, so everybody is free to build your own use case on top of our network. And yes, since some people asked, we are committed to open source. We have already opened up a small piece of our code base, and aligned with mainnet launch, we'll choose some time point to open source the whole code base. The user can take a look. Okay, yes, I have said a lot about our team, our core technology, our roadmap. Really, there are more to be done, and we are just getting started. So if you want more information, I encourage you to look at our website and to join our social media in Telegram, Facebook, Twitter, many other social media places. And also, to participate, you should look at our developer community, developer.org, and community.org. Another important piece is that we are looking for enthusiastic participants to become part of the Algoland community's leader, to be one of our ambassadors across the world. I believe we already have many good participants all over the world, and I really hope to have very enthusiastic developer or community leaders in Korea to help us grow the community. So if you're interested in becoming a community leader here, please go to the website and submit your application, or talk to me afterward, or talk to our partner, Block 72 afterward, and they will be very happy to bring you on board. All right, and yes, we are just getting started, and there are many things to come. We have a lot of innovative technology to be announced, and we are organizing a bunch of hackathon and developer events, and we are looking to launch our mainnet at some point. I'm not going to say a concrete time, but yes, more to come. And I'll stop here. Thank you very much.